So this is the evidence 1, part 2, and in the first problem, they ask us to get the frequency and the period of a ball that is tied at the end of a rope, and it's moving in circles. So they give us the velocity of 60 revolutions per minute, and to get the period, we have to divide 60 seconds between 60 revolutions equal to 1 second. To get the frequency, we divide 60 revolutions between 60 seconds equal to 1 hertz. The second problem says that we have to find the velocity of the vibration times of a turning fork, and they give us a frequency of 300 hertz and the amplitude of 2.2 millimeters. So first we have to convert these millimeters to meters, 0.0022 meters. And then we use the formula for velocity equals to 2 times p times frequency times amplitude. We substitute the values and we get the result 4.1469 meters per second. In the third problem, they give us a spring compressed. The distance is 35 millimeters, so we have to convert those millimeters to meters, 0.035 meters, and then with the constant of k and this value, we get the force. Then for the work, we have to multiply the force times the displacement or distance, and we get the result in joules. So for the potential energy, we have to use the formula of 1/2 of k times x to the square. We substitute and we get the value also in joules. In the fourth problem, we have a metal wire of 500 grams of mass and 50 centimeters of length. So they ask us the velocity. We have a force that is acting over the wire of 1000 newtons. And first we need to get the string density, dividing the mass over the length, 0.5 kilograms, converting those 500 grams to kilograms, and 0.5 meters. Equals to 1 kilogram per meter. Then we substitute this value in this formula that says that velocity equals to the square root of force over spring density, and the value is 100 square root 10 meters per second. In the fifth problem, they ask us the mass of a 4-meter length rope that is subject to a force of 300 meters, and they give us also the velocity of 150 meters per second. So we're clearing the formula of velocity equals to the square root of force over string density. We have the force and we have the velocity. So we just divide the force over the velocity to get the string density value. This value, we use it in the formula of the string density equals to mass over length. The length we have that is 4 meters. So we just multiply the meters times the value of the string density, and we get the result in kilograms of mass. In the sixth problem, they ask us the time it takes to the sound to travel through a piece of road of 2.5 long made of copper. So they give us the density of copper of 1,800 kilograms per meter cubic and the modulus elasticity of 1.17 times 10 to the 11 pascals. So we use the formula for velocity equals to the square root of y over the density. We substitute the values we have, and then we get the value of velocity. This value is necessary for the time formula equals to the distance over the velocity. So the time equals to 2.5 meters over the velocity we got in this part. Time equals to 6.8562 seconds. In the fifth problem, they ask us the intensity of a 55 decibels horn. And then we need to use the intensity of human hearing value of 1 times 10 to the minus 12. So we clear the formula to multiply 10 to the 55 over 10, and that value we multiply by the intensity of human hearing. So we get the value of 3.16 to the minus 7. In the 89 problems, we're going to use the same formula of frequency equals to initial frequency times velocity over velocity plus and minus final velocity. And also we're going to use the same value of sound velocity of 343 meters per second. So in the 8th problem, they give us a frequency of 56 hertz, and we substitute here the values of the sound velocity minus plus the velocity they give us of 60 meters per second. We're gonna get two different results in hertz because it's frequency. And in the second problem, the only thing that changed is the frequency and the have two different results altogether.